Okay, today's lesson in our unit Interactions and Ecosystems, our lesson is topic 5, Cycles in the Environment. Okay, so just going to resume here the recording. So we're looking at the carbon cycle first. So carbon substances may, over millions of years, change to become fuels such as coal, oil, and natural gas, which are fossil fuels. Respiration, or like breathing, will also give off carbon dioxide, so some carbon there. Animals on land will add that carbon dioxide when we exhale. That will be added to the air. In water, animals will add carbon dioxide to the water. Plants, during photosynthesis, they will take in carbon dioxide. All right, so they take in the carbon dioxide and then they release oxygen. Things like fuel burning factories, motor vehicles, and other factories that burn fossil fuels, they're going to be releasing carbon dioxide into the atmosphere. And lastly, we also have decomposers here that are adding carbon back into the soil and into the water. All right, so we can see how carbon is continuously cycled throughout the environment, but keep in mind that things like factory and vehicle emissions, they are adding more carbon into the atmosphere. So the water cycle, so very important because all living things require water. Just some comparisons here. Humans, we're 60 to 70% water. An apple is 84% water. A carrot is 88% water. And a tomato is 94% water. So when we're talking about the water cycle, there's these terms you are probably already familiar with. We have evaporation. Liquid water is changing into water vapor. Condensation, that's when the water vapor changes back into a liquid. So for example, warm air contains water vapor, but as air cools, the air is able to hold less water. Air becomes so cool, it can no longer hold that much of the vapor. The liquid water gets released. And that's what we see when we talk about clouds, fog, and dew. Then we'll have precipitation. That's when the liquid water forms from condensation, occurring inside clouds, and then it falls as either rain, snow, sleet, or hail. Another term here is transpiration. This is when water that is taken in through a plant's roots, it evaporates from the leaves, stems, and flowers, and then more water is taken up through the roots. And that's specifically in plants. We look, groundwater. This is the water in the soil. Plant roots can reach down to that groundwater. And when people are digging wells, they're also digging deep enough to reach that groundwater. And then runoff, that's water that runs off the ground and goes into lakes, rivers, or streams. All right, so here's a figure showing the water cycle. So if we start down at the bottom, that's our groundwater. You might have some surface runoff, which will eventually enter into the lakes or streams or rivers and so on. We have evaporation occurring. From evaporation, we have condensation and then precipitation. And here we can see the transpiration from plants. All right, so again, that's the loss of water from the leaves and the stems and flowers. Next, we're going to start talking about pollution in the environment. So when we talk about pollution, that's when a substance is being added to the environment at such a fast rate that it cannot be broken down. It can't be, it's being stored in the environment. It's It can't be broken down, stored, or recycled in the air, land, or water in a non-damaging form. So a pollutant, these are substances that cause the pollution, and substances that occur naturally can become pollutants. So when I was talking about the carbon cycle, we saw that in these factories and vehicle emissions, too much or excess carbon dioxide is being released into the atmosphere, which does become a pollutant. And again, that was because of burning fossil fuels. Okay, so first we're going to talk about acid rain. So this occurs when pollutants that contain sulfur and nitrogen are found in high levels in the air, and it's from burning fossil fuels. So here we can see from these emissions, there's sulfur dioxide and nitrogen oxide being released into the atmosphere, and it's mixing with the water vapor, and it's becoming an acid. So it's becoming sulfuric acid and nitric acid. So then when this falls now as precipitation, it's going to be damaging to the ecosystem. All right, so we have, for example, acid snow, acid rain, and so on. And any value with a pH value of below 5.6 is acidic. So just a quick review of the pH scale. When we look at the number 7 on a pH scale, that is neutral. As we move to the right and the numbers are increasing, it becomes increasingly basic. And as we move to the left of 7, that substance is becoming increasingly acidic. So we're saying here that water with a pH value below 5.6 is acidic. So 5.6 would be right about here. Anything below that is considered acidic. All right, next we're going to talk about PCBs. The PCBs, this stands for polychlorinated biphenyl. It was used in paints and packaging materials, and it accidentally was leaked into the air, the water, and ground through waste disposal sites. And these PCBs, they break down very slowly, and they remain in the ground or in the water for years, and they can cause a lot of harm to organisms. So what we're seeing here for PCBs here, they're being released into the environment, and it's being taken up by first plankton, then into animal plankton, and then it goes into invertebrates, and then fish, seabirds, and then larger marine mammals. And what we can see here is we're looking at the PCB concentration in milligrams per liter or milligrams per kilogram of fat. So what we see is how it increases as we go up the food chain, right? So comparing, for example, the smaller fish, it was 1 to 37 milligrams per liter, and as we go up into the larger marine mammals, it's gone up to 160 milligrams per liter. The next example is mercury. So mercury was used by many different industries, including gold mining, and it was disposed of as a waste. And this mercury leaked out of those waste disposal sites, and it dissolved in water. It would soak up into the ground. It'll end up in a body of water, such as a river or a lake, and then once it gets into organisms, it's very harmful to organisms. So in this diagram here, it's being emitted into the atmosphere, the mercury. Then it's being deposited into the ground as we have rain and snow and so on. It'll accumulate in lakes, rivers, and forests. It can also be transported through watersheds and then gets converted to methyl mercury, and then that methyl mercury can now bioaccumulate in the food webs. All right, so here's another example of mercury. So it enters the water, it leaks out of a waste disposal site, and it can leak into water. It'll enter the systems of microorganisms first, living in the sediment and algae in the water. Then the smaller fish down here, they're going to eat those microorganisms and the algae, and now that mercury will accumulate in their systems. And then the larger carnivorous fish. They're going to eat the smaller fish, and they're going to absorb that mercury from the smaller fish into their systems, and it stays in their fatty tissue. And then finally, humans, like if we catch these larger fish and we eat them, then now we have that accumulation of that mercury. All right, so notice how it's increasing as we go up the food chain. And that's what bioaccumulation is. Another example is DDT. So this was a pesticide that was used during the 1940s to 1960s, and it was being sprayed on crops and trees to kill insects. But it was also very poisonous and damaging to other organisms as well. It is banned in Canada, but it did destroy many bird species, like it destroyed like their eggs and so on. And so it caused the death of thousands of, for example, young eagles and hawks. It started causing the thinning of the eggshells. So bioaccumulation and biomagnification. So here, the first term here, bioaccumulation, that's the accumulation of a toxic chemical in the tissue of a particular organism. And biomagnification, this refers to the increased concentration of that toxic chemical the higher we go up in the food chain. This is just another diagram showing PCBs. So PCBs were being released into the atmosphere or into the environment, and then phytoplankton, they absorbed those PCBs. Then it went into the zooplankton, which eat the phytoplankton. Then we have these herring fish that eat the zooplankton. The salmon are eating the herring, and it's accumulating in their tissues. And then we have the larger mammals. In this example, it's the orca whales. They're eating the salmon, and we can see that biomagnification going up the food chain. All right, so I'll pause here. We have a few videos to watch. And then the homework for today was just the topic 5 review questions, 1 to 5 on page 54.
Have you ever heard the song Big Yellow Taxi? It's one of our favorites. It was originally written and recorded by Joni Mitchell back in the 70s, and there have been a lot of singers who have their own recordings of her song. It's a great song. The song has this verse in it that asks farmers to put away their DDT. You know when you're young and you don't understand a lyric in a song, so you kind of make up what that might mean in your head? Okay, well maybe that's just us. But we didn't really get that lyric until we got older, and now we do. And it's so much more powerful now. So, of course, it deals with science. DDT is a chemical pesticide, and it's called DDT because it stands for this. Yeah, so we're going to call it DDT. Its use really sparked in the 1940s as a powerful chemical pesticide, meaning it was used to kill insect pests. Often the types of insect pests that destroy crops, so it was popular in agriculture. DDT was very popular, but DDT soon came under some scrutiny. It became evident that this pesticide was having some negative environmental effects. In 1972, the EPA issued a cancellation order of DDT. And the EPA still works with other countries to control substances such as DDT and similar chemicals. DDT is used in other parts of the world, such as areas that are battling malaria and therefore looking for mosquito control options with indoor residual spraying. But it's definitely far more regulated and controlled in its use today. One thing that DDT really taught us is the effect goes far beyond the little insects that it may be targeting. Some high-level consumers, such as bald eagles, for example, really took a bad hit from DDT. For bald eagles, this affected reproductive abilities, including severe thinning of bald eagle eggshells. But why? After all, bald eagles do not typically eat the small insects that the DDT targeted. this takes us into our topic of biomagnification. And biomagnification doesn't just involve DDT. There are many chemicals and toxins that can be biomagnified. Mercury is another example that you might hear about. So when you think of anything being magnified, you think of it getting bigger, right? Well, biomagnification describes what happens when toxins become more and more concentrated in the living tissues of organisms as you go up in the food chain. But why does this happen? Well, take a look at these little bugs here. Imagine that perhaps these insects have been poisoned. Here are some still living poisoned insects. They're weakened, and some may make easy targets for predators. This poison is killing off a lot of the insects, but not all of them. Each of these insects will contain one triangle, which represents a concentration of that toxin. Now imagine these insects are eaten by secondary consumers, such as lizards or rodents, and as those secondary consumers eat those insects, the toxin concentration level increases in the secondary consumers. Why? Well, recall in the energy pyramid, organisms only keep 10% of the energy, approximately, from the trophic level below. The remaining is lost as heat, or undigested. That means that as you move up trophic levels, the animals will have to consume far more biomass from the level below to be able to compensate for this and survive. And everything it consumes from that trophic level below could have that toxin stored in its tissues, which now is an unwanted gift. It's adding up. Now, if a predatory bird begins to eat these secondary consumers, this concentration further increases. Remember, it only gets 10% of the energy from the trophic level below, and so as a tertiary consumer, it must eat a significant amount of secondary consumer biomass to survive, increasing toxin concentration in the tissues. The problem with many toxins or chemicals is that if they are not controlled well, they can get into the air, the soil, the water. With DDT, it was able to get into the water supply. Primary consumers, such as this small fish, began to feed on those producers. And the concentration in body tissues of the poison in the primary consumers increased due to biomagnification. Secondary consumers, such as the larger fish, feed on those primary consumers. The concentration in body tissues of the poison in the secondary consumers increased due to biomagnification. Tertiary consumers, such as bald eagles, feed on the secondary consumers, and the concentration in the body tissues of the poison in the tertiary consumers increased due to biomagnification. So in summary, biomagnification is a major factor to consider for any pesticide or chemical toxin that humans may produce. We need people like you to come up with new solutions. If you take a look at the end of our virus video, you can learn about a virus that has been used as a pesticide because it attacks specific types of pest insects. Well, what if viruses were manipulated to attack specific pests to avoid the use of a toxin? But even then, could there be consequences for taking out specific types of pest insects? One last thing to mention. Animals like bald eagles, they can face additional problems, such as habitat destruction, habitat loss, and poaching. There are ecologists who devote their lives to helping these organisms and raising awareness among people like you. Truly a career for the brave and bold. Well, that's it for the Amoeba Sisters, and we remind you to stay curious.